Welcome to the lecture series of Laplace Transform. Today we are going to see initial value theorem. Look at the statement of initial value theorem. If the Laplace transform of f of t and f dash of t exist and L of f of t equal to f of s, then limit t tends to 0, f of t equal to limit s tends to infinity s into f of s. So this is the statement of initial value theorem. Now we are going to write the proof. Look at the proof. First we will write the given one. What is the given? L f of t equal to, this we know very well because of the definition. This is nothing but Laplace definition. We have studied already Laplace transform of derivatives. With that notation, L of f dash of t is equal to, so result s into L of f of t minus f of 0, Laplace transform of derivatives. Based on that we are writing this one. So now according to the statement of initial value theorem, here it is given limit s tends to infinity. So in this place L of f of t, L of f of t is nothing but f of s. So this can be written as it is equal to s into L f of t is nothing but f of s minus f of 0. Now according to this result we are going to take limit on both sides, limit s tends to infinity. So taking limit s tends to infinity on both sides. So what will happen? Limit s tends to infinity, left hand side is L of f dash of t equal to limit s tends to infinity s into f of s minus f of 0. So now we have taken limit on both sides. Now this is nothing but limit s tends to infinity s into f of s minus f of 0 equal to limit s tends to infinity L of f dash of t. We have changed the sides, left hand to right hand side and right hand side to left hand side. Now L of f dash of t, limit s tends to infinity. Definition of Laplace transform. What is the definition? Integral 0 to infinity e power minus st f dash of t dt. Now when you are allowing the limit s tends to infinity, this integral will become as 0. Okay, when limit s tends to infinity, integral 0 to infinity e power minus st f dash of t dt equal to 0, because when we are allowing the limit s tends to infinity, this will become as e power minus infinity, value is 0, 0 and anything, the total integral value we can get 0. Therefore limit s tends to infinity, therefore limit s tends to infinity s into f of s minus f of 0 equal to 0. Now according to the result, this can be written as limit s tends to infinity s into f of s, take this to the right hand side, equal to f of 0. Now according to the result, this can be written as, instead of writing f of 0, the same thing can be written as limit t tends to 0 f of t. When we are allowing the t tends to 0, this will become as f of 0. That is the reason why instead of f of 0 we can write this as limit t tends to 0 f of t. Therefore the statement, what is the statement? Limit t tends to 0 f of t equal to limit s tends to infinity s into f of s. So we have proved the initial value theorem result. Based on the initial value theorem, we will do the problem. Look at the question. Verify the initial value theorem for f of t equal to a e power minus bt. So f of t is given. For this function, we are going to verify the initial value theorem. So the solution is, we know that the initial value theorem, what is the initial value theorem? Limit t tends to 0 f of t equal to limit s tends to infinity s into f of s. We are going to verify this result. That means what? We have to find the value of the left hand side as well as the right hand side. If both the values are equal, we can say that the theorem is verified. So now what is given? Given f of t equal to a into e power minus bt. Now we will go for the left hand side. Limit t tends to 0 f of t equal to limit t tends to 0 a into e power minus bt. When we are allowing the t tends to 0, this term will become as 1, that is e power 0, that value is 1. So automatically a into 1, we can get the answer as a. Okay. First part of the verification is over. Now we are going to find the right hand side answer. What is the right hand side? Right hand side is s into f of s. That means we have to find f of s first. So what is f of s? We know that f of s is nothing but L of f of t. Okay. L of, what is f of t? F of t is a into e power minus bt. A is a constant, so we can take outside Laplace transform of e power minus bt. So 1 by s plus b. Okay. So the answer is a by s plus b. What is our f of s? F of s is equal to a by s plus b. Now we can find the right hand side. What is that? Therefore limit s tends to infinity, s into f of s equal to limit s tends to infinity, s into, what is our f of s? F of s is a by s plus b. When we are allowing the limit s tends to infinity, this numerator is also s is there, denominator is also s is there. So we can get infinity by infinity form. So in that case we are going to apply the rule of L'Hospital's rule. What is the L'Hospital rule? We have to differentiate the numerator separately and denominator separately. After that only we can apply the limit. So applying L'Hospital rule, we can differentiate this. Okay, is a into s. That means a is a constant, function is s. So a into 1 divided by, when you are differentiating here, okay, when you are differentiating here, we can get only 1. S differentiation is 1 and b is a constant, it will become 0. So we can get the answer as a. Therefore limit s tends to infinity, s into f of s is equal to a. Therefore from 1 and 2, from both the equation we got the answer as a. Therefore from equations 1 and 2, initial value theorem, that is limit t tends to 0, f of t equal to limit s tends to infinity, s into f of s. Got the same answer. Look at the second question. Verify the initial value theorem for f of t equal to e power minus 2t sin t. So this problem is also similar to the previous one. So first we will take the given f of t. For the given f of t, we can take the Laplace transform, that is nothing but f of s. Okay. So L of, what is f of t? F of t is e power minus 2t sin t. Okay. So this is nothing but L of sin t, where s to s plus 2. Okay. So what is L of sin t? Sin t is 1 by s square plus 1, where s to s plus 2. So this is our f of s. Now we know that the initial value theorem is limit t tend to 0, f of t equal to limit s tends to infinity, s into f of s. So we will take the left hand side, limit t tend to 0, f of t equal to limit t tends to 0. What is our f of t? E power minus 2t sin t. When we are allowing the t tend to 0, sin 0 is 0, 0 into anything 0. So we got the left hand side answer is like this. Now for the right hand side, limit s tends to infinity, s into f of s. Limit s tends to infinity, s into, what is our f of s? F of s is 1 by s square plus 1, where s to s plus 2. Okay. So limit s tends to infinity, s into 1 by s plus 2 the whole square plus 1. Okay. Now we are allowing the limit s tends to infinity. What will happen? This will become as infinity by infinity form. Okay. S tends to infinity means infinity by infinity. So in that case again we are going to apply the L'Hospital's rule. So applying the L'Hospital's rule, we can get differentiating numerator and denominator. So when you are differentiating the numerator, we can get 1, and for the denominator 2 times of s plus 2. Now we are allowing the limit s tends to infinity. So what will happen? 1 by infinity. Anything by infinity, answer is 0. So we can call this as equation 2. So from equations 1 and 2, in both the equation we got the answer is 0. Therefore, from equations 1 and 2, initial value theorem, limit t tends to 0, f of t equal to limit s tends to infinity, s into f of s is verified. Okay. So this is the way we have to do the problem under initial value theorem. Thank you for watching.